March 2026. A stage in Shenzhen, Huawei lifts a single card into the air. 1,056 trillion calculations a second. Almost 3 times the most powerful AI chip the United States still permits into China. 3 years ago, America's top semiconductor analysts gave Beijing a decade before anything like this existed. That timeline didn't slip, it collapsed. No EUV machine from ASML. No memory chips from South Korea. No trace of Nvidia's CUDA anywhere inside it. Every rule Washington wrote to stop this. Bypassed, obliterated. 8 days before this stage lit up, Nvidia's own CEO called what was coming a disaster. He was describing the end of a $3 trillion empire, and he did not know it yet. Nvidia's empire ran on something most people outside the industry had never heard of, a software layer called CUDA. Nvidia released CUDA in 2006, a toolkit almost nobody outside chip design cared about. Then in 2012, a neural network called AlexNet used it to win an image recognition contest by a margin nobody could explain away. That single result rewired the entire AI industry's hardware choice overnight. By the time Washington tightened the restrictions, thousands of Chinese engineering teams had already spent years writing production code specifically for CUDA. Every one of those teams represented a sunk cost that made the wall look, for a while, unbreachable from the inside. By 2026, GPT, Gemini, Llama, every model that mattered had been trained inside that same ecosystem. Abandoning it meant rewriting the building from the foundation up. This wasn't Washington's first attempt to choke a rival's chip industry. In the 1980s, similar restrictions targeted Japan's semiconductor dominance, and Japan eventually opened its market under sustained pressure. That precedent shaped every assumption inside the Commerce Department this time around. Trade restrictions had worked before. Nobody expected the target to build its own alternative from zero instead of negotiating a settlement. When Washington moved to cut China off from Nvidia's newest chips, Nvidia didn't abandon the market. It engineered a workaround, a crippled, castrated piece of silicon built solely to slide under export restrictions while keeping Chinese cash flowing into California. They named it the H20. Walking away from China entirely was never a serious option for Nvidia. The country represented too large a share of global AI chip demand to abandon outright, even at reduced margins. Half a loaf, however crippled, still beat losing the bakery. The restriction wasn't cosmetic. Memory bandwidth cut by roughly half compared to Nvidia's global flagship. Enough for everyday inference, nowhere near enough to train a frontier model. And still, in a single year, Chinese buyers handed Nvidia an estimated $12 billion for it. The strategy was cold and calculated. Feed China just enough compute to survive, never enough to compete. For a moment, Nvidia's 95% market monopoly looked unbreakable. Washington believed that without Western tools, Western memory, and CUDA, a Chinese alternative was mathematically impossible. Every analyst in the room agreed. That consensus held for years. It did not survive 18 months. The chip Huawei raised in Shenzhen has a name. The Atlas 350, built around Huawei's own Ascend processor, nearly 3 times the raw power of the chip it was built to replace. This is not the first time sanctions accelerated the exact outcome they were designed to prevent. Huawei's own smartphone division survived an almost identical playbook back in 2019, when a components ban cut it off from Google services and advanced chips alike. That earlier squeeze produced Harmony OS and Huawei's own mobile chip line. The Atlas 350 is the same lesson, replayed at a much larger scale. Huawei didn't undercut Nvidia on price. They matched it exactly. $16,000, the same budget Chinese buyers had already set aside for the American chip. Same price tag, triple the output. Chinese procurement officers had already built entire budget cycles around that $16,000 figure long before Huawei ever set a price. Matching it exactly meant no internal justification was needed to switch suppliers. Here is the part most coverage missed. Washington didn't just cap the H20's raw compute. It forced Nvidia to throttle the connection speed between chips. Train a large model, and you don't use one chip. You chain thousands together, cripple that connection, and the chips sit idle, waiting on each other, no matter how fast each one runs alone. That single bottleneck is why data centers across China started calling the H20 an expensive paperweight. Not because it was weak on paper, because it choked the moment you tried to scale it. It is a strange irony that the same interconnect bottleneck engineers had long flagged as the real limit on large model training became the exact lever a trade restriction chose to pull. Alibaba, Tencent, ByteDance had spent years buying the crippled chip anyway because there was no alternative. The moment Atlas 350 shipped, that reluctance ended. Orders went in at production scale, not as a test. Huawei's AI chip revenue is projected to hit $12 billion by the end of 2026, up from $7.5 billion the year before. That money didn't appear from nowhere. It is cash that used to land in Silicon Valley. Nvidia's share of China's market collapsed from roughly 95% to something close to zero. Jensen Huang confirmed that number himself. $50 billion in annual revenue? Gone. With every sign it isn't coming back. Designing a chip that beats Nvidia on paper is one battle. Manufacturing millions of them without a single machine from ASML's most advanced production line is an entirely different war, and it's the one Huawei had not yet won. Here is the war nobody saw on stage. SMIC, the company that manufactures Huawei's chips, has 0 EUV machines on its production floor. That single tool is the one piece of equipment ASML is legally forbidden from selling to China. So SMIC took an older tool, DUV lithography, built around a light wavelength of 193 nanometers, and forced it to etch patterns fine enough for a 7 or 5 nanometer chip. That gap between the light and the target is the entire problem. To close that gap, SMIC runs the same layer through the machine 4 separate times, a technique called self-aligned quadruple patterning. 4 passes instead of 1. 4 chances for the wafer to shift by a fraction of a nanometer and misalign. Multi-patterning isn't some desperate improvisation unique to China. TSMC and Samsung used the exact same technique years earlier, before EUV machines existed in commercial volume anywhere in the world. What's different this time is that SMIC has no exit ramp. TSMC eventually graduated onto EUV. SMIC, under sanctions, cannot. An overlay error that's small is invisible to the human eye. It is also enough to turn an entire wafer, one that costs real money to produce, into scrap silicon. That single risk, multiplied across 4 passes instead of 1, is why SMIC's yield sits well below what TSMC achieves on the same node. Every additional pass through the machine also means more time occupying a production line that could otherwise be running other orders. Capacity that Nvidia's suppliers spend on 1 wafer, SMIC spends on 4, which quietly caps how many Atlas 350 units can physically exist in a given month, regardless of demand. Huawei's answer wasn't to chase precision it couldn't reach. It was to stop betting on one large die entirely. Split the chip into smaller chiplets, each easier to manufacture without a fatal defect. Then bond them back together on a single package using 3D stacking, the same category of technique behind TSMC's own advanced packaging lines. That fix comes with a real cost. More chiplets packed this tightly generate more heat in a smaller space, and they draw meaningfully more power than a single clean die would. Huawei's data centers now run liquid cooling loops sized for a problem most chip designs never have to solve. Liquid cooling at data center scale isn't a plug-and-play fix either. It requires trained technicians, redundant pumps, and leak detection systems most Chinese data centers never needed to install for a standard Nvidia rack. That is one more hidden cost, stacked on top of the chip's own price tag. None of this is efficient. It is expensive, power-hungry, and harder to cool than anything Nvidia ships. But on a stage in Shenzhen, the chip ran. A working chip means nothing if nothing runs on it. CUDA had spent 2 decades turning itself into the one gate every serious AI lab had to walk through. Beating Nvidia on silicon was only half the war. Open ecosystems have broken proprietary moats before. Linux eroded Unix's grip on servers. Android did the same to mobile operating systems that assumed hardware lock-in was permanent. DeepSeek's release followed the identical pattern, except this time, the moat wasn't an operating system. It was the assumption that serious AI required American silicon underneath it. 8 days after the Atlas 350 lit up that stage, a Chinese lab called DeepSeek released a model named V4, 1.6 trillion parameters, a context window of 1 million tokens, and one detail buried in the technical report that mattered more than either number. The model had scrubbed Nvidia out of its own computational chain entirely. Engineers rewrote the core kernels from scratch, line by line, so the model could run natively on Ascend silicon instead of anything CUDA ever touched. Releasing model weights publicly is a different kind of openness than releasing source code. Anyone can read code and understand every decision behind it. Weights are closer to a finished brain, powerful to use, but nearly impossible to reverse engineer the reasoning that shaped them. That distinction is exactly why Western labs could copy the results without needing to copy China's underlying research process. That kind of rewrite is brutal. Line-by-line work most labs avoid entirely, because CUDA's 2-decade head start means millions of existing lines of code simply don't exist for any other hardware. DeepSeek's team built that missing code from zero. Washington had spent 4 years guarding shipping containers, tracking every lithography machine and every advanced chip crossing a border. None of that stopped a file. Open source weights move at the speed of an internet connection, and there is no customs checkpoint for that. Inside the Commerce Department, the realization landed hard. The entire containment strategy was built around physical borders. This threat had none. Officials began floating restrictions on the platforms hosting the open weights, an idea that triggered immediate backlash across the global developer community. DeepSeek wasn't a name that appeared out of nowhere either. Its earlier model, released months before V4, had already climbed into serious international benchmarks and forced several Western labs to publish rebuttals defending their own numbers. V4 wasn't a debut. It was a second, harder punch from a lab the industry had already underestimated once. The weights were already public by then. Within a month, teams in Singapore were running V4 against the exact H100 shortage that had made cloud compute prohibitively expensive across Southeast Asia. In Germany, automation labs frozen out by Microsoft and AWS pricing found a model they could finally run on hardware nobody could sanction. For the first time, a serious slice of the global open-source AI community had a genuine high-performance alternative that required no American hardware and no American permission anywhere in the chain. SMIC's yield on this node sits below 40%. TSMC's sits above 80%. That gap alone means every working Atlas 350 costs roughly double what an equivalent Nvidia chip costs to produce. Beijing absorbs that gap. State subsidies quietly cover the difference, letting Huawei sell each chip to domestic buyers at roughly the same price as the American original. The cost didn't disappear. It moved onto a government balance sheet instead of a corporate one. This financing pattern isn't new either. Chinese solar panel makers used the identical playbook a decade earlier, absorbing losses long enough to outproduce Western competitors on cost, until subsidized volume alone became the deciding factor. Chips are simply the newest industry to receive that treatment. The smuggling routes never closed either. Shell companies in Dubai and Singapore keep reselling Nvidia hardware relabeled as ordinary server boards, and Chinese labs still rent H100 clusters through cloud providers sitting outside any sanctions list. There is also no long-term reliability data yet. Nvidia's chips have a decade of field failure statistics behind them. Atlas 350 has months. Nobody outside Huawei's own labs knows yet how these chips age under 3 years of continuous high-heat cluster operation. At the extreme edge of frontier research, training the single largest models that exist, Nvidia's top chips still hold a measurable 10 to 15% performance edge, but roughly 95% of commercial AI workloads never touch that ceiling. For almost every buyer that matters commercially, the gap is already irrelevant. Even the 10 to 15% frontier gap is not fixed. It has narrowed twice already since the Atlas 350 launched, each time a new Ascend firmware update shipped. Nvidia's lead isn't eroding because of a single breakthrough. It is eroding one incremental patch at a time. What's unfolding here isn't a war either side can win outright. It's a war of attrition, where China absorbs cost through subsidy, and Nvidia absorbs loss through shrinking market share, and neither bleeding stops on its own. Washington built its export controls to starve a rival of a resource it could not replace. What it actually did was force that rival to build a parallel supply chain it no longer has any leverage over. Inside the House Select Committee on the Chinese Communist Party, the reaction was immediate. Members called for an emergency review of the entire export control framework. The policy had one job, and the Atlas 350 was sitting proof that it had failed. Silicon Valley's own semiconductor lobby pushed back hard, and not out of principle. Tighter restrictions meant less access to the very market their sanctions had just handed to a competitor. Politicians wanted a harder wall. The industry that had to live behind it wanted the wall gone. The telecom industry saw an early version of this same split years earlier, when several nations chose between Huawei's 5G equipment and its Western rivals based on price and political alignment rather than pure technical merit. AI hardware is now following the identical fault line, just a decade later, and at far higher stakes. The Allies paid the real price. SK Hynix and Samsung watched a memory market they had treated as permanently theirs start slipping away. ASML lost a meaningful share of its China revenue overnight, the exact market the Netherlands had been pressured to shut down in the first place. ASML's dilemma cuts especially deep because the company depends on China for a meaningful slice of its total order book even after the restrictions, while holding a monopoly on the one machine Beijing cannot yet replicate. Every euro of lost revenue funds indirectly the very Chinese engineering effort trying to make ASML's monopoly irrelevant. Washington had asked its allies to sacrifice a real market to serve an American strategy. That strategy just handed the market to Huawei anyway. The allies noticed exactly whose bill they were left holding. Here is the paradox nobody in Washington planned for. By banning the competitor, the sanctions didn't create an open market. They created a protected one, a captive customer base with nowhere else to buy. And Huawei was the only seller standing inside it. There are early signs domestic lithography research in China is accelerating since the Atlas 350 launch, a signal that the EUV gap, not the chip gap, may be the next target everyone races to close. Chinese companies that once bought Nvidia purely for convenience are now pouring tens of billions into Huawei because there is no alternative left standing. Washington didn't just fail to stop a competitor, it built that competitor a monopoly. And it isn't only China choosing sides now. Governments across the Middle East and Southeast Asia face the same fork. Buy American infrastructure and you accept Washington's political conditions attached to it. Buy Chinese infrastructure and you get something increasingly rare: immunity from a sanctions regime that no longer touches you. The internet that once ran on a single global stack is splitting into two. Not by accident, and not because either side wanted it this way. Because the wall built to contain one competitor ended up building an entire second internet standing next to the first. Go back to that stage in Shenzhen. The card raised in the air wasn't just a chip anymore. It was the visible tip of a chip, a memory standard, a software framework, and a frontier model, all built without a single American component inside any of them. Washington spent years building the most sophisticated export control system in history to make sure this exact moment never happened. China built it anyway, not despite the restrictions, through them. Trade historians have a name for this pattern. They call it the boomerang effect, when a restriction meant to weaken a rival forces that rival to become self-sufficient in exactly the area it was blocked from. It has happened with oil embargoes, with steel tariffs, and now, for the first time, with silicon itself. So here is the question worth sitting with. If the wall built to contain a rival is the exact thing that taught it how to build everything on the other side of that wall, does export control still work as a weapon? Or did Washington just write the blueprint for its own replacement?